Welcome to Module 2, Unit 2. In the previous video, we discussed registers. At the end of this video, you should be able to list the 3 categories of registers, state the types of registers, and mention the functions of each register. Categories of registers. Registers are to be used for certain purposes, and the rules governing the role of the register should be followed strictly. Registers are grouped into 3 major categories. They are general purpose register, control registers, and segment registers. Here is a simple chart depicting the categories of registers. Now we have our register, which is divided into 3 categories. The first one is the general purpose register. Then we have the other one, which is control register. The third one is segment register. Now the general purpose register is divided into 3. We have data register, we have what we call pointer register, and index register. Now the control register consists of 32 bits instruction flag. We call them instruction flag, IF. 32 bits instruction flag. While the segment register is divided into 3, which we have the code segment, which is written as CS. Then we also have the data segment, and lastly is the stack segment. So all these are the major categories of registers that we have. Each of these will be discussed in the next slide. The general purpose registers, as I've said, consist of number 1, data register. The main function of data register is to contain the initial data for the result of arithmetic or logical instructions. The registers in this group can be used as a 16-bit accumulator register known as AS or abbreviated as AS, or BS base register, CS count register, and DS data register. The next register under general purpose register is a pointer register. The pointer register consists of 16-bit instruction pointer that is abbreviated as IP, stack pointer, which is abbreviated as SP, and base pointer, which is also abbreviated as BP. The pointer registers are used to store the offset address of the next instruction to be executed. It keeps the offset value within the program stack and helps in referencing the parameter variable passed to a subroutine. The index register. The index registers consist of 16-bit index register, which are source index, which is abbreviated as XI, destination index, which is abbreviated as DI. They are used for indexed addressing and sometimes used in addition and subtraction operations. The control registers. The 32-bit instruction pointer register and 32-bit flags registers are combined to form the control registers. Several instructions and operations that involve comparison and mathematical calculations often change the status of the flags, and some other conditional instructions that test the value of the status of the flag to take the control flow to other location. Some of these control registers are overflow flag, which is abbreviated as OF, direction flag, which is abbreviated as DF, interrupt flag, IF, trap flag, TF, sign flag, SF, zero flag, ZF, auxiliary carry flag, AF, parity flag, PF, carry flag, CF. Now overflow flag. Overflow flag, it indicates the overflow of a high order bit, leftmost bit of data after a signed arithmetic operation. In other words, an overflow flag, we have a sign of 1 or 0 after a signed arithmetic operation. Direction flag. This is used to determine the left or right direction for moving or comparing string data. So a direction flag, we have 1 if you are moving from left to right, and it's going to have 0 if you are moving from right to left. Interrupt flag. This determines whether the external interrupts like keyboard entry, and so on are to be ignored or processed. An interrupt flag, we have 1 if you enable an interrupt, for instance a keyboard entry, and it will have 0 if you disable it. Trap flag. It allows the setting of operation of the processor in single step mode, so we could step through the execution one instruction at a time. So if a trap flag has 1, that means the trap flag is enabled, so there is an execution of one instruction at a time. Otherwise, if it is 0, it is disabled. Sign flag. It shows the sign of the result of an arithmetic operation. 0 flag. This is used to indicate the result of an arithmetic or comparison operation. Auxiliary carry flag. It contains the carry from bit 3 to bit 4 following an arithmetic operation. Parity flag. It shows the total number of 1 bit in the result obtained from an arithmetic operation. Carry flag. This contains the carry from a 0 or 1 from a high order bit, leftmost bit after an arithmetic operation. The third category of register is the segment registers. Segment registers are divided into 3. We have code segment, which is abbreviated as CS. It comprises of all the instructions to be executed. A 16-bit code segment register or CS register stores the starting address of the code segment. Data segment, which is abbreviated as DS. It comprises of data, constant, and work areas. A 16-bit data segment register or DS register stores the starting address of the data segment. Stack segment, which is abbreviated as SS. It comprises of data and return addresses of procedures or subroutines. It is implemented as a stack data structure. The stack segment register or SS register stores the starting address of the stack. With this, we've come to the end of this video. See you in the next episode. Thank you.